Well, let me start by thanking the organizers and for those who nominated me to be here today. And I still like to start with this picture showing the beauty of the mother city in Cape Town. And as I heard some audience members saying, it would be a nice place to have the next conference. I agree totally. It's a lot less airtime for me, air travel. I thought it was also important just to put you in that perspective. You may have heard of a university called University of Cape Town, but very few people have ever heard of the University of Stellenbosch. This is a map of the peninsula, and this is Cape Town. University of Cape Town is around here. Stellenbosch is out there, produces the most fantastic red and white wines, and its medical school is situated at a place called Tygerberg, and that's where I'm situated, just so that you're all orientated. I thought I'd start this talk with this picture of Jan van Riebeck coming out from the Netherlands as part of the Dutch East India Company to start a refreshment station in Cape Town in around the middle 1600s. And what this picture depicts for me is this interface between the Europeans and the natives in South Africa, the Europeans being the bringers of disease. When tuberculosis was introduced into South Africa is not really well known, but there is some anecdotal evidence to sort of suggest how this epidemic has evolved over time. In around 1800, it was documented that consumption was relatively rare in South Africa. By 1880, there were a large number of Europeans coming out to South Africa for having sun therapy in the very nice climate in the Karoo region, bringing with them their strains. In about 1912, about 32% of miners were shown to be have tuberculosis. This probably reflects that the mining context was the incubator of where the interface between European miners and African miners came together, spreading disease, incubating the disease, and then these migrant miners would move back to their homelands or places, houses far away, and then spread the disease into the country. And as one can see in the next red point, in 1925, 66% of rural black people were infected with tuberculosis. The situation subsequently has shown a dramatic increase in the incidence of disease in South Africa, has probably arguably one of the highest incidences worldwide, probably driven by HIV, and I would like to also think that there is some problems with the healthcare system. And the change here may reflect the introduction of a more standardized treatment. So currently the epidemic is largely associated with socioeconomically deprived people who reside under these basic conditions shown in these different pictures. So with all South Africa being the juncture point between Asia and Europe, one can imagine that all the travel that came around the Cape brought in strains that were endemic in Europe and endemic in Asia, brought them to South Africa, leading to our population structure of strains being extremely diverse, probably representative of the global phylogeny. And without going into much detail, basically one can group these strains into these different groupings according to SNPs or spoligotype patterns or DNA fingerprinting. But the idea of this is just to show that there's a tremendous diversity in South Africa. But the population structure is very different in the different countries in this, Southern Africa. For example, one sees down here for South Africa that we have this red group, which is the Beijing strain. Some of you may have heard of it. And one can see that it's also present in Mozambique, a little bit in Zimbabwe. And then the strains from the Mediterranean seem to be very, very dominant. But the idea of what I'm trying to show here is that the population structures are very different, probably reflecting the way colonization happened and what strains were first seeded, they had a foothold in the setting and then predominated, very difficult for other strains to outcompete those. The treatment of tuberculosis in South Africa probably was quite haphazard in the early years, and in the mid-60s became a bit more formalized with the use of isoniazid, PAS, and streptomycin. And this went on until the early 80s, where then, or late 70s, when rifampicin came into the regimen, and then in the 90s, the regimen became the standard WHO. But this selective pressure has had, I think, quite an influence on the strains in South Africa over the years. And looking back at some of the literature, it's quite clear that in the early years, there was a lot of isoniazid and streptomycin resistance. These little surveys have done in different places in South Africa. The Western Cape is where I'm from, and then these other surveys have been done in South Africa and on the mines. And this decline in resistance in the 70s going into the early 80s is suggestive of a much more organized TB control program rather than just a haphazard. But it does appear that some of the data now from Helen, who will speak after me, that the incidence of resistance is a lot higher than is predicted when one does a national survey. The focus of much of the work and of drug resistance in South Africa has been on MDR. And the funny thing is that we tend to be focusing towards the future, not looking back at the past, and not taking into account what the past is actually, how the past has actually influenced the present. And I think by putting this talk together, I sort of feel now that the way we treated patients probably in the 60s is influencing what we're seeing in the epidemic today, and we really need to understand this. But what we're seeing is that MDR TB is really increasing. And it's a question of whether it's through acquisition, through poor adherence, or whether it's through transmission. And defining those balances will give us a good idea of where we should be targeting diagnostics and interventions. But most of these control strategies stem from the recommendations of WHO and from surveillance data. And as Helen pointed out yesterday, percentages tend to hide the reality. And what we're seeing is that this high proportion of treatment cases having MDR has led to a focus in terms of the diagnostic and treatment algorithms, not taking into account the fact that if we look at the actual number of cases, predicted cases, there's significantly more cases that have no previous history than cases that have a previous history of treatment, suggesting that transmission is one of the dominant driving forces. This has, I think, serious implications and is one of the reasons why the epidemic has evolved and is becoming such a major issue in South Africa, is because we have categorized patients into low and high risk and then defined on what the way we will manage those patients subsequently. And as one can quite clearly see, the low-risk groups get a 4-drug regimen with no drug susceptibility testing, which is a standard recommendation, whereas the high-risk group do get now a 5-drug regimen and DST. And the consequence of this is that there is a risk that there is amplification of resistance in the group who have resistance to isoniazid and rifampicin and are then subsequently treated with a 2-drug regimen. And to try to demonstrate that this is the reality of the situation, there was a study done on a mine recently. And basically, this study looked at an outbreak of this family X strain, which is thought to originate from England, showing how this outbreak evolved. And what I just wanted to try to highlight was, if you imagine yourself as a MDR case with no previous history of treatment, you'll be put onto this 4-drug regimen, and there you are sitting in the phylogenetic tree, and you're actually getting a 2-drug treatment, ethambutol and pyrazinamide. There's a risk that you spread this disease to your contacts, particularly if you're hospitalized, that you gain additional resistance. And this is exactly what happened. Pyrazinamide resistance occurred on 2 separate occasions, then subsequently spreading that strain to contacts. Those contacts then get treated with the same sort of inefficient regimen. And as you can imagine, now there's a grave risk because you're on monotherapy of ethambutol, and we see a sudden evolution of resistance in this particular phylogeny, clearly demonstrating that if we don't have drug susceptibility testing early, there is a grave risk of amplification. And we feel that this is a situation that's happening not only on this particular mine, but in the whole of South Africa. And just to point out some studies that we've done showing that there's a very strong association between ethambutol resistance and MDR in a study done in 2006, repeated in about 2009, showing that nearly 50% of MDR cases have markers for ethambutol resistance. Pyrazinamide the same, nationally and more locally where I am in the Western Cape, implying that we have gone from an MDR epidemic to an MDR plus epidemic. The epidemic, if we look at it in terms of strains, is also interesting, that we see that there is, again, very different population structures. And I wanted to highlight in particular that as one can see here, if you remember in one of the previous slides I showed that there was this Beijing genotype, and that time the quadrant was in red. Here it is much more dominant. This strain appears to be able to either acquire resistance more readily or is a much more fit strain that once resistant is able to spread a lot more easily. And we see that in the Western Cape and the Eastern Cape. But up in KwaZulu-Natal, it is not dominant at all amongst MDR cases, but is present in the susceptible population. In Gauteng or in Johannesburg area, we see a much more of a homogeneous population, probably reflecting migrant workers towards the gold mines in that area. Interestingly, if we look at these Beijing strains, we can subgroup them into different categories. And just for simple terms, it's typical is often found, and atypical is rarely found. That's the names that were given to them. One can quite clearly see that this Beijing population is very different from that Beijing population in terms of the atypicals being dominant and here being very rare, showing that we have very different epidemics in terms of the population structures in different provinces of South Africa. Within this MDR population, there's been a number of papers describing outbreaks, 3 of which were Beijing and 3 of which are non-Beijing. This is the famous KwaZulu-Natal outbreak, which I think in some ways put TB back on the map with the discovery of XDR TB and the high mortality associated with that. Just looking at those outbreaks a little bit more carefully, I just do a couple of them just to show. Here we see the outbreak that is this 5-bander strain. It happened in a town northeast of Cape Town. And the phylogeny, despite using resistant markers, which are not perhaps the best markers for reconstructing a phylogeny, but they give us an idea that streptomycin and isoniazid were, in fact, the first evolutionary events to happen, suggesting, as I indicated right in the beginning, that perhaps in our distant past, treatment with isoniazid and strep and PAS were the factors that caused this strain to evolve. And subsequently, it evolved rifampicin resistance on numerous occasions. And as it acquires more and more resistance, the more it is able to spread. So the highly resistant strains spread, but the other ones, the less resistant, appear to spread less. And the second example of an outbreak strain is this Beijing strain, first identified in a school outbreak. And then when we looked more closely at the epidemic, we found that in fact it was one of the dominant strains in the Western Cape area. And looking at 2 different time intervals, we could show that the epidemic was not only increasing in time, having a doubling time of about 8 years, but the majority of this increase over time was driven by this particular strain here, which is called the R220, as I showed earlier in the slide, having a doubling time of around 2 5.3 years. But if we look at only the MDR strains, it has a doubling time of about 1.5 years, which is quite frightening, implying that this strain is really fit. Wow, time. Okay, I'll skip on this one. This supports the idea that MDR strains are spreading extremely quickly. What the reaction to the MDR is to use a treatment regimen of 5 drugs. These 5 drugs include the 2 drugs that I showed that are largely associated with resistance in MDR, implying that, in fact, our treatment regimen is extremely weak, using only 3 drugs that would be effective in a large proportion of the cases. In a recent study, we showed that, in fact, if you treat a patient with rifampicin prior to knowing that they have MDR treatment, you can induce ofloxacin resistance, which implies that perhaps instead of being a 3-drug regimen, which is weak, it's perhaps now down to a 2-drug regimen, which obviously leads to the evolution of XDR. And we see this in that mine setting, that fluoroquinolone resistance appeared subsequently, and then aminoglycoside resistance, leading to this red dot of XDR. If we look at XDR, I think it's really interesting to note that the population structure of MDR, which treated with this weak regimen, led to an amazing selection of this Beijing genotype in the Eastern Cape, the Western Cape, and in KwaZulu-Natal. The population structures, as one can quite clearly see, are very, very different. Almost all of this XDR outbreak appears to be one strain in the Eastern Cape. Why did this happen? Well, the commonality between all of these XDR strains is that they all have an INH-A promoter mutation. For those who don't know, there's a very strong association between the INH-A promoter mutation and cross-resistance to ethionamide. So what do we have? Almost zero efficacy in a treatment regimen, just 2 drugs left, and one could question whether the ofloxacin is working well. So obviously there's a risk with those strains being the ones that are more likely to evolve and acquire additional resistance. These XDR strains I showed initially, this is the KwaZulu-Natal outbreak. In the Western Cape, we see there's apparent outbreaks. These are the strains that are highlighted, that the MDR strains, in fact, are becoming the XDR strains. The dominant MDRs are becoming the dominant XDRs. In the Eastern Cape, as I showed here, one particular strain driving this epidemic. From that DNA fingerprinting data, it appears that there's this massive outbreak. The question is that real? So what we've been doing is looking at fingerprinting data, superimposing a targeted gene sequencing to try to understand what is really happening. And here we see the idea of an outbreak. If we look at mutations conferring rifampicin resistance, there are in fact 2 lineages. Those 2 lineages are maintained if we look at resistance to pyrazinamide and ethambutol. And then if we look at resistance to ofloxacin, quite clearly there are numerous mutations implying that probably these MDR cases are poorly managed and allowing for this emergence of resistance to fluoroquinolone and becoming XDR. Here's another representation of this. This is the Eastern Cape strain, just showing that it is a clonal outbreak initially with resistance to isoniazid and streptomycin, again coming back to this theory of whether these strains were born in the 60s, and then evolving off in their own little branches. And this is just the superimposed on whole genome phylogeny. The end shows that the fluoroquinolones are evolving independently. And just speeding things up, but just to show you that what we're observing in monitoring these patients over time is that initially patients who are diagnosed with MDR treatment put onto fluoroquinolone, and we see the mutations conferring resistance starting to evolve and then becoming cemented in the population. And there's just 2 examples. The reason that this is happening, I think, it really needs further investigation as to what are the risk factors of why these patients are developing resistance and are now going over time. What I'd like to put forward is perhaps we've reached a point where we've really got totally drug resistance rather than XDR. If we look at the strains that are dominant in our population, they're resistant to all of the drugs that we use, except we don't really know anything about PAS, and cycloserine is not very easy to test. But I would like to put that in your minds that, in fact, that may explain why treatment success in these two studies have shown very poor outcomes. And I think that in KwaZulu-Natal, if one looks back at some of the data, that also demonstrates totally drug resistance. The response has been to revamp the treatment regimens. I'm still wondering what is going to be the impact without taking into account the knowledge that we know in terms of, in certain populations, INHA promoter mutations are very common, so this drug may not be as effective as people think it is. We know that pyrazinamide is a potential problem, and recently, and together with many others, have shown that if you have resistance to kanamycin or amikacin, you also have cross-resistance to capreomycin. So leaving a rather difficult situation in terms of treatment, desperate need for new drugs. And finally, time is up to say thanks to all of the colleagues in the lab and for everybody that's been working with us over the past few years. And thanks. Evening sunset in Cape Town. Thanks.